Hey guys, I'm going to talk about solving inequalities, specifically more just one-step inequalities here. So if you haven't watched my basic inequalities video on how to graph them and graph the solutions, you need to watch that because when I get to the actual graphing part of these, I'm going to go a little bit faster. Um, it's kind of understood when you watch this. You have some prior knowledge and we're just building on it now. So we're going to solve the following inequalities and graph their solutions. So I have x minus 7 is less than or equal to negative 4. Now, when we're solving these, it's just like solving equations, okay? The only difference is there's an inequality sign in the middle, which, and once we get going here in my series of videos, we're going to have to be a little bit careful with that. But in general, you're just solving just like we would solve equations, which means we got to get x by itself by working the order of operations backwards. So if I want to get x by itself here, I worry about this minus 7. Negative 4 is on the other side. I worry about the minus 7. The opposite of subtracting 7 is add 7 to both sides. If we do that, the 7's here, those are opposite, minus 7 plus 7, that's gone. So we have an x is less than or equal to negative 4 plus 7, which is 3. So now what I want to do is I've solved the inequality, but I want to graph my solutions. That way I can visually kind of look and see all the solutions to this inequality. So I have a less than or equal sign, which means I need a closed circle at 3. So there's my circle, and I'm going to close it. Now I got to figure out, do I want to shade towards the 0 or away from the 0? And the way to do that is plug in 0 into the equation. If the inequality is true, shade towards. So true, we're going to go towards 0. If it's false, we're going to go, and what I kind of use there is away from 0. So true, we're going to go towards 0. False, we're going to go away from. So if I plug in 0 into this inequality, I have this, that, and this, which this reads 0 is less than or equal to 3. So we have to ask ourselves, is this a true or false statement? Is 0 less than or equal to 3? It is. This is a true statement, so I need to shade towards the 0. So that's towards the left in this case. So I highlight everything over here, and I can put an arrow to the left. What this means is all these numbers that are shaded, including the 3, since it's a filled-in circle, if I plug in any of these numbers over here into this original inequality, they're all solutions here. They're all going to give me correct and true inequalities. That's what this means. So all of these are solutions, not just 3. And yes, because of the equal sign, it is 3. All of these numbers are solutions. So now that we kind of have a quick overview, I'm going to go a little bit faster now. So 16 is greater than 4x. Again, we're trying to get the x by itself, so the focus is on the right side. This is multiplication, so I'm going to divide by 4, divide by 4. So I have 16 divided by 4, which is 4, is greater than, and that would be x. So 4 is greater than x. I'm going to go to 4, and I should have an open circle. I'm going to plug in 0, and I'm going to see if it's true. I'm going to shade towards 0. If it's false, I'm going to go away from. So I have 4 is greater than 0, which this is true. So I'm going to go towards 0. So I'm going to go to the left here. Now I went a little bit quick through there. If you need to skip back in the video to hear that again. But I'm building here. We're building knowledge, so we're going to go a little bit quicker on more of these basic ones. A few more problems for us here. I have 3x is greater than or equal to negative 9. So again, the focus is on the x. So I got to get this x by itself. Order of operations backwards. This is being multiplied, so I'm going to divide by 3, divide by 3. That gives us an x is greater than or equal to negative 3. Going to go to my graph, going to go to negative 3, and because it's greater than or equal to, we're going to have a filled-in circle at 3. And then I'm going to plug in 0 to figure out if I'm going towards 0 or away from the 0. So if I plug in 0, 0 greater than or equal to negative 3. And I got to ask myself, is 0 greater than or equal to negative 3? It is. It is true, so we're going to go towards the 0. Well, 0's on the right. So I shade this little bit over here. Just like that. Now, this next problem, you might be like, all right, I get it. What's the point? Next problem, we're going to start exploring a few little interesting ideas. And everyone, it's a common rule, but it's commonly forgotten when dealing with inequalities. It is that whenever you multiply or divide by a negative, you're going to flip the sign. So multiply or divide by a negative, flip the sign. Okay. What I mean by that is if it's opening to the right, keep it the same, but just open it to the left. So if it was a less than or equal to, it changes to a greater than or equal to. So if you multiply or divide by a negative, flip the sign, flip the inequality. So 15 is less than negative 5x. Got to get this x by itself. So we got to get rid of this negative 5. So that means I'm going to divide by negative 5, divide by negative 5. 15 divided by negative 5 is negative 3. But notice, I divided. In red, I wrote here, divide, negative 5, divide by negative 5. So we're going to flip here. Okay, so it's going to open this way. The common mistake here, and this is why I did this example up here, is we don't care about, say, the numerator here. I did negative 9 divided by 3. It's what I write on both sides that matters. I wrote on both sides divide, negative 5, divide, negative 5. But up here I wrote divide by 3, divide by 3. It's a much bigger difference. So dividing by a positive number up here, yes, this is a negative 9. What matters is what I wrote on both sides. Divide by a positive 3, divide by a positive 3. This is divide by a negative, divide by a negative. So there is a difference there, but we did divide by a negative 5 there, so we're going to flip the sign. So that's why I flipped it. Negative 5s are gone, so I just get an x. And when it comes to graphing, it's business as usual, what I've been doing the past few. So I'm going to go to negative 3, and I should have an open circle. And I need to plug in 0 to see if I'm going to go towards or away from. So if I plug in 0, I'm going to have negative 3. That right there. Negative 3 is greater than 0. So they're saying negative 3 is bigger than 0. That is not true. That is false. So we need to go away from the 0. So the 0 is to the right, so I need to go away from it, which is to the left. So we're going to go left and put in arrow. Last problem of this video, x is divided by negative 2 is greater than or equal to 3. Again, two sides of this. We are dividing by negative 2, and the focus is on the side with the x. We are dividing by negative 2, so I need to multiply the left by negative 2, and I'm going to multiply the right by negative 2. See, I wrote in a multiplication by negative 2 on both sides. Left side are negative 2's, that is, we're multiplying and divided by negative 2. They're gone, so I get an x. Because I multiplied both sides by a negative, we're going to flip the inequality. On the right side, 3 times negative 2 is negative 6. Go to the graph, go to negative 6. We should have a closed circle. And if you plug in 0, we're going to have 0 less than or equal to negative 6. So 0 is less than or equal to negative 6, or you can look at it and say, they're saying negative 6 is bigger than 0. That is not true. That is false, which is all the area to the left. So that was solving inequalities one step. Do remember, if you multiply or divide by a negative, you have to flip the inequality. And that was solving inequalities one step.